Okay, guys, welcome back to Mr. Morrow's class, Algebra 1. Today we're going to jump into Chapter 2, and we're going to use all of the skills from Chapter 1 and really put them to application mode, okay? We're going to be learning how to solve equations. We're also going to be writing equations, okay, solving word problems with equations. A little bit later in the chapter, we first have to learn how to walk before we run. But remember, so far, you should have in your belt, perfect, adding, subtracting, multiplying, and dividing all real numbers, positive and negative. So that means by now you should know how to add, subtract, multiply, divide fractions, decimals, negative numbers, everything. You should know how to evaluate. That's when you are given the value for a variable and you plug it into an expression and solve it. You should already know, like a master, the order of operations. You should by now know all of the properties of mathematics, the commutative property, associative, distributive, identity, etc., etc. You should know all of the subsets of real numbers, rational numbers, whole numbers, natural numbers, integers. You should know what irrational numbers are. All of this stuff, I promise, is going to come back and either aid you or hurt you, depending on whether or not you've learned it already. So as a friendly reminder, if you have not learned any of those things, or you're still a little bit stuck or a little bit rusty, please go to my lesson videos for Chapter 1, please, and thank you. So okay, today we're going to talk about equations. We learned last chapter in 1-9, if you remember, we did mental math, solving equations, and then they had this crazy little table, remember, and we'd have to plug in values. That's going to be a good skill that we're going to learn later. But today we're going to learn how to really solve equations using real procedures, okay? These procedures don't ever change. And the goal for solving one-step equations is to isolate the variable. That means get the variable all by itself. That means I want to solve for positive x over 1. Why x over 1? Because I want x to stay in the numerator. If you ever see it in the denominator, we'll learn how to do it, but you need to move it to the numerator. We always want to solve for positive x. You don't want to solve for 2x or negative 3x or negative x or half x. You want to know what x is, alone, x, and only x, my brothers. So that's the goal of every single equation, starting from nice simple ones to extremely hard multi-step equations. Solve for the variable. Get the variable all by itself, positive and in the numerator. Does that goal make sense so far? Simple goal, but really important. Now, there are 4 beautifully easy steps here. Number 1, bless you. You undo addition with subtraction. What does that mean? Well, do you guys remember the property, the additive inverse? What's the inverse of positive 3? What's 3 minus 3? Okay, so that's why I say you cancel out addition with subtraction. Okay? Vice versa, you undo subtraction with addition. Okay? So let's think about the additive inverse. What's the opposite of negative 3? Or what's the inverse of negative 3? Positive 3, yeah. What's negative 3 plus 3? 0. So remember, whenever you're using the additive inverse, when you use the inverse and you apply the additive inverse, the sum is going to be 0. So that's why I said you undo or even cancel out addition with subtraction, and you undo or cancel out subtraction with addition. Same thing for multiplication and division. You undo multiplication with division using the multiplicative inverse property, or the inverse of multiplication property. What is the inverse of 5? The multiplicative inverse of 5. The multiplicative inverse. Negative 5 is the additive inverse of 5. What is the multiplicative inverse of 5? 1 over 5. Very good. It's the reciprocal. Remember reciprocals when you flip a number upside down. Okay? The multiplicative inverse deals with reciprocals. Okay? If I have 7, the multiplicative inverse is the reciprocal of that, which is 1 over 7. When I multiply these together, I get 7 over 7, which equals 1. Whenever I use the multiplicative, bless you, whenever I use the multiplicative inverse, okay, my answer is going to be 1. That's why I undo or cancel multiplication with division. Last but not least, I undo division with multiplication. Okay? I'm going to use, again, the multiplicative inverse. And this one's very important. Okay? A lot of people don't like fractions. You have to know how to use them, but I am going to show you some tricks to help you out. If I were to give you something like this, okay? The 5 is in the denominator, correct? X and 5, what is the relationship? Are they being multiplied, divided, added, or subtracted? Divided. So how do we cancel out division? Okay, but we're going to use inverses, right? So what is the denominator here? What is invisible up here by the X? A 1, very good. So multiplied by the reciprocal. 5 over 1 is the reciprocal. Blink. X equals 10. Shabam. Does that make sense? We're going to do a whole bunch of examples today, but I just wanted to make sure that these first steps make sense, especially with the multiplicative inverse. So again, when you apply the additive inverse, the answer is going to be 0. Negative 5 plus its additive inverse of 5 is 0. When you apply the multiplicative inverse, your product is going to be 1. 5 times its reciprocal, which 5 times its multiplicative inverse of 1 over 5 is 5 over 5, which equals 1. Yes, sir. Come again, son? Son, what did I just do? I did exactly that. I multiplied to both sides. No, I do not want you to do it that way. I want you to do it my way. My way is the best way to do it. The problem is this, okay? This is the way a lot of you guys were taught, for example. And there's nothing wrong with this. It's just very elementary. A lot of you guys start doing this to me. Okay? That division symbol is a thing of the past, guys. That's gone. That's bye-bye. You just can't do that anymore. So if you're going to divide, then divide by 3. Okay, x equals 5. Now, what you were saying, my man, you have x over 2 and then equals 5. Okay, what were you told to do, sir? Okay, so you bring the 2 over. Okay, that technically is wrong, though. So whoever taught you that is technically wrong, because what they're showing you here, you're only doing something to one side of the equation, correct? No. What happens in an equation is whatever you do to one side of the equation, you must do to the other side. So you have to show to the reader, hey, I'm multiplying by 2 over 1 to both sides. That keeps it equal. So technically, unfortunately, that way that you were saying, sir, it's kind of right, but not really technically right. Because you have to do whatever you do to one side of the equation, you must do to the other side. Whatever you do to one side, you must do to the other side. Does that make sense? Awesome. Thank you, my brothers. Now let's practice, okay? We're going to practice for the rest of the class now. Okay. Just bear with me. Ask the questions that I ask. All right? Ask the questions that I ask, and you're going to see how life is a lot easier for yourself. This is what I do always. Okay. N plus 27. Okay. What's the relationship between N and 27? They're being added. What's the sign of the 27? How do you undo that positive 27? You subtract 27 to both sides. Remember, whatever you do to one side of the equation, you must do to the other. So N is going to equal, that's 9, 3, yep, 19. Positive. Because when the signs are opposite, you subtract, keep sign largest absolute value. Yes, sir. Yes, I want you to show all the work. Yes, all of the work. Now, a lot of you are going to say, Mr. Morrow, please, come on. We can do this in our head. Please, sir. I understand, guys. I know you can do some of these in your head. I know. But trust me, I'm building the skill of how to follow procedures on an equation. If you start learning how to follow the procedures on the simple equations, then it gets easier when you get to the more difficult equations, and then it gets easier when you get to the super difficult equations. So I beg you, actually I don't beg you, this is, you have to do it. There's no choice. You have to show me all the work. On homeworks, quizzes, and tests, you have to. Even if it says x plus 1 equals 2, I want to see that you subtracted 1 to both sides. Does that make sense, guys? Trust me, I'm doing this not to hurt you, but to help you later. If you know how to do the easy stuff properly from beginning to end, it makes everything easier. Please. And thank you. Good question, sir. Okay, 4 equals q plus 13. What's the relationship between q and 13? They're added. They're being added, not positive. Positive is not a relationship. They're being added. What is the sign of the 13? Okay, how do you, bless you, how do you undo addition? So you subtract 13 to both sides. So q equals -9. Remember, when you have opposite signs, subtract is normal. 13 minus 4 equals 9. But keep the sign of the largest absolute value. There's more negatives than positives. So I have -9. J minus 3 equals -7. What's the relationship between j and -3? Excuse me. Subtraction. How do you undo subtraction? So I'm going to add 3 to both sides. So j equals -4. Very good. Remember, when the signs are opposite, you subtract as normal and keep the sign of the largest absolute value. There are more negatives than positives, so it's -4. What is the relation between the p and the 7.1? They're being added. What's the sign of the 7.1? Well, how do you undo addition? So you subtract 7.1 to both sides. Those cancel. P equals, when the signs are the same, you add and keep the sign. So it's going to be -9.6. Y minus 19 equals 37. What's the relationship between the y and the 19? They're subtracting. What is the sign of the 19? Negative. How do you get rid of subtraction or negative? You add 19. Use the additive inverse. So you add 19 to both sides. Add those bad boys up, and you're going to get y equals 56. Are you with me so far, guys? That's how we solve single-step equations using addition and subtraction. Now we're going to go to some multiplication and division. Does that make sense so far, gentlemen? You promise, gentlemen? Okay. Thank you, gentlemen. All right, let us continue, please. -7y equals 28. What's the relationship between the -7 and the y? Now, here's where it's tricky. Sometimes people add 7. Why is that wrong? Because you're multiplying. Thank you very much, son. You have to have something in between. Okay, there's nothing in between, then that means you're multiplying. Okay? So, how do we get rid of multiplication? Division. So I'm going to go ahead and divide -7 to both sides. -7 divided by -7 is 1, so I'm left with a y equals -4. What is the relationship between the 4 and the x? Multiplication. How do you get rid of multiplication? Division. So I'm going to divide 4 to both sides. 4 divided by 4 is 1. I'm left with 1 times x, which is x. And then 4 goes to the -96. You got -20, -24, correct. Now, I'm going to do it over here so you can see exactly all the work. What's the relationship between the m and the 7 here? Division. Remember, when we're dealing with division or with fractions, simply get rid of that fraction by multiplying by the reciprocal to both sides. You see what I'm doing there, guys? Remember, cross divide. 7 goes into 7 one time. I'm left with m. And that equals 12 times 7, which is 84. Does that make sense, boys? Okay. Now, I'm going, son. Number 9. I've got k over 4 equals -17 over 2. What is the relationship between the k and the 4. They're being divided. How do you cancel out division? Okay, but you're going to multiply by the reciprocal. So I'm going to multiply 4 over 1 to both sides. 4 divided by 4 is 1. 1 times k is k. I'm left with k. Now I can cross divide. 2 goes into 2 one time. 2 goes into 4 2 times. Negative 17 times 2 is negative 34. What is the relation between the 2 and the x here? Multiplication. How do you cancel out multiplication? Division. So I'm going to divide 2 to both sides. 2 divided by 2 is 1. I'm left with an x, and that equals negative 24 divided by 2, which is negative 12. Bear with me, because now I'm going to get into real heavy fractions. Excuse me. Okay? Let's continue. Now, let's practice some good ones with fractions. All right. Check it out, my brothers. Please don't stress, but rather focus. Pay attention. What is the relation between the 2/3 and the x? They're being multiplied. How do you get rid of multiplication? Okay. Don't write this down. Don't write this down for 1 second. Technically, this is what you're supposed to do. Divide by 2/3. Then that cancels. And then that's stay, change, flip, and then that'd be 27. That's technically what we have to do. But there's a lot of steps there. There's a lot of room for error. So what I'm going to choose to do is the trick that I just finished teaching you. Multiply by the reciprocal, and in one step, you do it all, my brothers. So what is the reciprocal of 2/3? Heck yeah, 3 over 2. So I'm going to multiply 3 over 2 to both sides. 3 divided by 3, it's 1. 2 divided by 2 is 1. I'm left with x. That equals 18 over 1 times 3 halves. Can I cross divide? 2 goes into 2 one time. 2 goes into 18 9 times. 9 times 3 is 27. And you didn't have to do the stay, change, flip. You didn't have to divide it to both sides. You do it in one fell swoop. One step, done. You're done. 3/4 x equals 9. What is the relation between the 3/4 and the x? They're being multiplied. How do you get rid of multiplication? But when we're dividing fractions, we really multiply by the reciprocal. Cancels. X equals 3 goes into 3 one time. 3 goes into 9 3 times. 3 times 4 is 12. You guys with me? Okay. Now, 2/5 x equals 4/7. What is the relation between the 2/5 and the x? Multiplication. How do you cancel out multiplication? But when you have to divide fractions, what do? You multiply by the reciprocal. So I'm going to multiply by 5 over 2 to both sides, gentlemen. 5 divided by 5 is 1. 2 divided by 2 is 1. I'm left with x, which equals 2 goes into 2 one time. 2 goes into 4 2 times. And that's going to be 10/7, which equals 1 3/7, gentlemen. Does that make sense? Yes, sir. The question was, can we leave it in the improper form? No, usually not. Okay, sir. Thank you, sir. Now, let's see. Let's separate the people who are really trying and those who still need to work a little harder. What is the relation between the 2 and 2/3 and the x? Okay, how do we cancel multiplication? Division. But wait a second. Can I have a reciprocal to this? No. What do I have to do first? Yes, thank you. Whenever you're dealing with multiplication being, when you have a fraction, I'm sorry, scratch that. When you have a mixed number being multiplied to a variable and you're solving for that variable, you cannot divide by the mixed number. You must convert it into an improper fraction first. So that's going to be 8/3. 2 times 3 is 6, plus 2 is 8/3 x equals 12/15. Now, what is the relationship between the 8/3 and the x? How do I get rid of multiplication? Division, but I'm dividing a fraction, so I multiply by the reciprocal. Very good, sir, gentlemen. So I multiply by the reciprocal. X equals 4 goes into 8 2 times, 4 goes into 12 3 times, 3 goes into 3 1 time, 3 goes into 15 5 times, 3 times 1 is 3, 5 times 2 is 10, 3/10 is your answer. Okay? Now, bless you. I have now your favorite when we're having addition of fractions. Okay. A lot of people know how to do fractions, and what they'll do is they'll subtract 1/3 to both sides and then find a common denominator and all that good stuff. But be honest with me. Do you really want to do it that way? No. Okay, with all due respect, you do have to know your fractions, but at the same time, I got a trick for you guys. I got an easy way out here, okay? You can get rid of all the denominators if you multiply both sides of the equation by the LCD, the least common denominator. What's the least common denominator between 7 and 3? Okay, so check this out, okay? I multiplied both sides by 21. 21 times 2 is 42, and then of course 1 times 7 is 7. Distribute. 21 times 1, 21, and then 1 times 3, 63. Okay, no. And then distribute here. 21 times A would be 21A. Are you with me so far, guys? Okay, let me just move this. Whoa, wrong thing to do. Sorry. I meant, no. Forget it. Look, what's 42 divided by 7? 6, no more fraction. What's 21 divided by 3? No more fraction. Plus 21A. Now, does that make sense, guys? Now, look, subtract 7 to both sides. -1 equals 21A. You with me? How do I get rid of the 21 that's being multiplied to A? Divided by 21. A equals -1 over 21. Are you with me, guys? Now listen, for this one here, real quick, for number 6, I wouldn't do it that way because I have the same denominator. When I have the same denominator, it's much easier just to go ahead and do the math. So in this case, I have a -4 2/3. I add 4 2/3 to both sides. And I'm going to get x equals, that cancels, 2/3 plus 2/3 is 4/3. 2 plus 4 is 6. But 4/3 turns into 1 1/3. 1 1/3 plus 6, 7 1/3. So in this case, okay, it would be better to do it that way. But if you have different denominators, like in number 5, you can get rid of the denominators by multiplying by the LCD. May God bless you all. Have a great day. Bye-bye.